I would like to introduce the speaker first of all. The speaker is Lucinda Offer. She's the Education Outreach and Events Officer for the Royal Astronomical Society in London, which is a professional academic organization, and it advocates for astronomy, geophysics, and space science in the UK. She was the executive director of the Mars Society USA from 2009 to 2021, and this society works to prepare humans for living and working on Mars. They do 2-week simulations at their habitats in Utah, in the United States, and in the Arctic. She's the chair of the National Astronomy Week in the UK, a honorary visiting fellow for Bayer School of Business at City, University of London, and she's an expert at the UK space industry and the Mars Society. As a former NASA associate, she participated in 4 NASA spaceward-bound expeditions to the Mojave, Australia, Abu Dhabi, and New Zealand. She was researching tardigrades, which are 3.5 billion years old, stromatolites, Mars and Titan analogs, and geothermal vents, respectively. She was also a NASA analog mission teleroboticist for Crew 97 at the Mars Desert Research Station in 2011, and she tested and deployed the rover to work along the future crews. She has done a lot of things. This is a very rich background that we are telling you here, but she's also a credentialed science teacher in both the US and the UK, and has taught Earth and space science, physics, and astronomy since 2004. She currently teaches astronomy at the Royal Astronomical Society's headquarters in Burlington House, and she loves community, people, working together towards common goals, and playing cooperative games. She actually has prepared also a quiz for us at the end of the talk, and she became a lifetime member of the Mars Society in 2002. So basically today, she's going to talk to us about the remarkable journey of the Herschel family, and how did they contribute and they made such a big difference in the astronomy world. So I don't want to take more time from Lucinda. I would like to invite her on the stage. And Lucinda, the floor is yours.
Oh, thank you so much. Good morning, everyone. I can see that there are more students who are coming into the Zoom classroom. Just going to wave and say good morning. Scott, nice to see you. Hi, I can see you waving back. It's wonderful. Thank you so much for joining me. Oh, what a lovely welcome. So thank you, Nasia, for that very, very nice introduction. Yes, we're going to talk about the Herschel family today. These were ordinary people who ended up doing extraordinary things just from being curious. Before I get started, though, on talking about this amazing family, I do want to share with you some pictures of some of the things that Nazia pointed to in my introduction. I have been doing education and outreach about human space exploration for over 20 years. I'm a field scientist in geology, geosciences, geophysics, which basically means I study the Earth. I study the composition of the Earth and the physical processes of the Earth. I love being outside in the field, touching the rocks and life and seeing life in our beautiful planet. And I love working with people from all different places. And I've been so lucky enough with all my different jobs at the Mars Society, with NASA, and even here with the Royal Astronomical Society, which is bringing me to different countries other than where I'm at now, England, allowed me to travel and meet lots of different people. And I see we have a classroom from Turkey, and other classrooms. If you could put in where you're from in the chat box, I'd love to know how many different schools and where you are located. But my jobs also allow me to be very artistic and creative, so not just scientific. I actually have 2 degrees in science and art. I love art and design, and I want to combine those two to talk about science, which is one of my favorite subjects. How many of you have subject is science? Your favorite subject? Anyone in the rooms? Raise your hand if science is your favorite subject. All right, I see a few. Oh, excellent. A little bit more than maybe, I'll say 50%. And this gentleman right here in this image, this gentleman is an astronaut, and his name is eluding me right now, Charles. I think I can't remember his surname at the moment, but he was a pilot who flew. If anyone recognizes him, feel free to put it in the chat. But he flew this space shuttle for many years, and I got to meet him in person, and I've met Buzz Aldrin, lots of really, and Tim Peake, who's a British astronaut, lots of really amazing human beings who've pushing humans to Mars. All right, let's see. So I am here to talk to you about this family, the Herschels, a very talented family. One was a musician, they loved to play instruments. Another one was a housemaid. She had to take care of her mother back home and clean the house and cook the food. And another one was a young child who was raised among scientists at the time. So I'm going to tell you about all three of them. So in the upper right-hand corner here, we've got Sir William Herschel. He was the musician and a composer, and he eventually became an astronomer just out of sheer curiosity. And he was also the first president of the organization I currently work for, the Royal Astronomical Society, and that's what the letters RAS mean. And then Carolyn Herschel just below him, and she was the housemaid who was living in Germany, and became an astronomer, had the skills to become an astronomer, and eventually she would find comets just by looking at data. And then John Herschel here between them is a William's son and Caroline's nephew. He was a polymath. Polymath. I know it has the word poly, which means many, and math, which sounds like mathematics. What it really means is he had skills and interests and was good at lots of different sciences: biology, chemistry, physics, astronomy, geology. He was really good at them all at the time. And he was the co-founder of also the Royal
Right.
Astronomical Society, and he was an inventor, and he was an influencer actually. If Instagram existed in his day, he would have had more than 1 million followers, I'm sure. So he was really good at influencing people, especially scientists. So let's start with William, the father. He was ended up being a huge discoverer of amazing things. I'm going to tell you about him. And he was also really good with his hands. He liked to make things and tinker and think about what could be. And so those were the basic skills that he had. Even though he was good at playing an instrument or composing notes, he wanted something else. He was interested in something bigger than himself. He made telescopes and incredible discoveries. Just trying to get through my next slide. So, and this was just all of curiosity and tenacity. He was just curious about the world around him. And that actually opened the door to a new profession for him. So he was originally from Germany, a place called Hanover. And when he was very young, just finishing his secondary school, and he was 18, became 18, he was being forced to join the military because his country was heading towards war. And so he fled. He was able to flee to another country, to the United Kingdom. So he was an immigrant. He was, as I mentioned, interested in, he played instruments so that he could make money. And when he came to England, he ended up throwing big events where people could dance and listen to music and meet each other. This was a really big thing in England at the time. So that was the way he made money when he got there. But he was looking up at the night sky and was very, very much enthralled by looking up at the stars. But what he really wanted to know was what's all between those points of light in that dark space in between called deep space. How do we see those things in the darkness of the sky? Not where there are points of light, but where there is darkness. So he was curious about deep space, and but the tools at the time for astronomy, which is called the study of the stars and the moons and the planets, those tools didn't exist. There wasn't yet a telescope that could see that far. So he was naturally curious, he was scientifically minded, and he was determined, and that's called tenacity. He was so determined that he was going to take action towards, you know what, the tools don't exist. I'm going to build them or I'm going to get help to build them. So he started to bring in his family. His brother, who was a woodworker, would help him build these telescopes. And his sister, eventually, I'm going to talk to you about her, would help him observe deep space. So these are some pictures of William Herschel. Well, this is an illustration on the left. And here he is. He's making a lens out of glass that he made himself in his home in Bath, England, in the United Kingdom. And you can see he is polishing this lens. And this lens is bigger than has ever existed before. And he's going to use that lens that his brother Andrew would build a telescope and he would put that lens in there. His work became so valued that astronomers from all over the world ordered telescopes from him. So out of his own interest, he went from music and composing music to throwing dances, balls in Bath, to actually forwarding science by making the tools that didn't exist anymore. And you can see his sister here, Caroline, who he brought over from Germany to help him because he needed someone to help keep the house. Or you see in this picture here, he needed someone to feed him while he was working day and night to create all these orders for new telescopes around the world. So as he's polishing this lens, she's feeding him and making sure he gets nourishment to keep going because he had a lot of work to do. Eventually, he made a telescope. Here's a 6.2-foot telescope that he made with his brother Andrew, and this is a replica at the Museum of Bath in England. And this is a very important telescope I'll talk to you about in just a moment. And then you can see this huge telescope on the right. You can see the people are right down here. This is a 40-foot telescope. There's a little house in here where he could sit and stay warm and do notes. And maybe Caroline was in here helping him do observations. And you can see up here, there's a deck, a stairway that goes up to a deck. And then there's a little basket here that he would stand in. And he would look down the telescope to look at deep space. To be honest, this telescope wasn't so great for that. But what it was it was the largest telescope of the time that it drew people to England to see it. Astronomers were interested and had no idea that you could make telescopes this big or see images that far away in space. What happened was it made him the king's astronomer. So he went from a musician to throwing parties in Bath to becoming the king's astronomer just by being so incredibly interested in what he couldn't see. So he became very popular. He actually would throw parties in his back garden with this telescope in England, and the king would bring his guests over. And so he continued to entertain people, but he was entertaining people for the king. So what did he do with that 6.2-foot telescope? Well, with this telescope, he actually discovered another planet. And we know it today as Uranus. But at the time, it was called Georgium Sidus, or George's star. And it was King George at the time. And so we could have ended up with, instead of a planet called Uranus, George. But it's not called George, it's called Uranus. So and we know the planet. So I'm going to show you what actually that did at the time. He actually doubled our known solar system. So I know you can't imagine that now. And I know you're probably still be thinking about what happened to Pluto, right? We have, so let's take a look at what we knew was our solar system back in 1780, before William discovered this planet. So at the time, of course, here we are. Here's Earth. We're the third planet from the sun after Mercury and Venus. And you see here, Earth is 1 AU. AU means an astronomical unit. It's just an arbitrary unit that we invented to mean the distance between the Earth and the sun, the average distance between the Earth and the sun. And so we call that 1 astronomical unit. And you can see then we have the asteroid, we have Mars, and then the asteroid belt. And Jupiter here is, we'll say, approximately 5 astronomical units, 5.2 to be accurate. So that means that Jupiter is 5 Earth distances away from the sun. So if we could kind of 1, 2, 3, 4, 5, right? And then Saturn is, I say it's 9.6 astronomical units, but I like to round up to 10, right? So basically, at the time. That Saturn means that's 10 Earth distances away from the sun. So if we continue, we do 5 more here, distances of the Earth to the sun, all the way to Saturn. So that's all we knew. That's how big our solar system was in 1780. We only knew of Saturn. We didn't know of any of the other planets that existed in our solar system. So when William Herschel discovered Uranus with his 6.2-foot telescope that he and his brother and his sister actually built, he doubled the solar system because Uranus was almost 20 astronomical units away from the sun. So that doubled the distance in our solar system. That was pretty amazing thing. And that discovery is what got the king's attention and made an 18-year-old boy from Germany the king's astronomer. But of course, we know that we have another planet in our solar system called Neptune, discovered in 1846, not by William Herschel, but it was discovered because of the discovery of Uranus. Uranus was wobbling, and they realized that something else in the night sky was affecting Uranus's orbit, and they could contribute it to other things like the sun. Saturn would affect Uranus's orbit. Jupiter, because these are large planets that have a lot of gravity, they would affect Uranus's orbit. But mathematically, they could also tell that something else was out there orbiting in the night sky that was affecting Uranus's orbit. And that's how they discovered Neptune. Another thing that William Herschel discovered was this invisible type of light called infrared. And you can see in this picture, here he is with one of his telescopes here in the back of him. And you can see, hopefully you recognize his 40-foot telescope. And that's how we know this is William Herschel. And here he is, he's here with a prism up here by this window that is breaking up light. So if you ever get a glass prism and put it up with the light from the sun shining through, you'll see how many different types of light combine to make what we see as white light. And this is the optical or visible spectrum. I grew up, and you can tell by my accent, I'm American, perhaps. I grew up in California, where we said Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, to remember the order of visible light. But what he discovered was, and he's got these thermometers outside of the visible light. So this is what we see, our eyes as human beings on this planet. We evolved to be able to see these colors of the rainbow, we can call them as well. But outside red was another kind of light that we can't see, this invisible light that he actually got a temperature of. So each of these have a different temperature. And as he moved outside of the red visible light spectrum, he had these thermometers here, and he was doing a scientific experiment to find out what is out there. And the reason he came upon this accidentally was because he was using his telescope to look at the sun. Don't look at the sun. Don't look at the sun with your eyes. Don't look at the sun through a telescope, because you need to have a special filter to protect your eyes. Because what he was doing was he was damaging the rods and cones in his eyes by looking directly at the sun. And he wanted to create a filter to protect his eyes. And that's what we use today. So he started thinking, I can't look at the sun. It's hurting my eyes. What's going on? And that's how he came upon this experiment and discovered infrared, a type of wavelength that's invisible. So here are the different wavelengths from the sun. We pass them through a prism, and we can see, as human beings, these colors all around us in our planet. But we can't see infrared. We can feel it in our skin. So if you go outside on this sunny day, you feel this heat from the sun, and that's infrared light. And that's what he was feeling on his eye, which is not good. And so this is what he was looking at. This is our star, our closest star, the sun. And this is a sunspot on the surface of the sun. So he was trying to look at those, but was failing, but made an amazing discovery from that. And so this is what we use infrared for now. So we use infrared light to look at objects in space. The James Webb Space Telescope is just that, a space telescope. William was making telescopes in his house on the ground observational telescopes that look at the night sky from Earth. We've had those since his time and before, Galileo and Galileo. And this is a space telescope. We can now launch telescopes into space, and we can look at other objects in our night sky. So this is called the Pillars of Creation, and this is looking at this object with mostly optical and a little bit of a near infrared, not of higher infrared wavelengths, but with better technology. Sorry, this was done with the Hubble telescope with JWST looking at other wavelengths of infrared. We can see through the cloud and dust. So this is what infrared wavelengths of light allow us to see in space. They allow us to see through the clouds and gas, and you can see so many stars being born in this clouds of dust, this pillars of creation. So this is what different wavelengths of light in astronomy allow us to do. We can see through some of that clouds and dust and see what's actually happening inside some of these amazing things that are happening in space. Here's another image of a very familiar planet, Jupiter. You can see in optical invisible light that our eyes can normally see every day. On the right, it's invisible light. That's what we normally see as our planet Jupiter. And on the right, we're looking at it with a telescope using infrared, and it allows us to see below the upper atmosphere of the planet. So using infrared light in astronomy is important because it allows us to see more than our eyes can actually see. So we can learn more about these objects in our night sky. So let's quickly move on to Caroline Herschel, his sister, who he brought over from Germany to help him create all these amazing new tools and help him with his discoveries. She ended up doing discoveries of her own. She's known as the Comet Hunter. So she emigrated to the United Kingdom at the request of her brother, William. She worked as a housemaid, as I mentioned, in Germany, and she also did that in the UK for a while, but she started to help him. She was sort of his scientific assistant on that huge 40-foot telescope. So she started to record data for him and help him make his observations. She would tell him where to look. It was so large of a telescope, she would help him keep it all organized and create catalogs for him. She became, from using all those skills that she herself had and learned from by working with him, she became an astronomer in her own right. She made her own discovery of a nebula in 1783. In 1786, she discovered her own comet, and she discovered 8 further comets in her lifetime from 1786 to 1797. She has a comet named after her, 35P Herschel Rigolette, and she's just been pretty amazing. I wanted to show you how perfect her handwriting was and how organized and detailed her notes were, meticulous, that probably her brother William could not have done what he did without her help, keeping everything so organized. She was so good that she could look at other astronomers' catalogs and find mistakes, find objects that were missed, and she would fix them. And that was actually something that her nephew John continued to do as well, which is improve star catalogs for astronomy. So she became the first paid professional female astronomer, like that as we know it, that existed initially. And she then went on to win the Royal Astronomical Society gold medal. That's a huge thing as a woman in that time of the world because, for instance, women weren't allowed to be part of societies or allowed memberships or considered scientists, but she was making these discoveries herself. You could not deny that she was an astronomer. She went on to get a salary from the king, which was a huge thing as a woman. She received 50 pounds in 1787 annually from King George III. And in 1828, that's when she received the gold medal from the Royal Astronomical Society. And she also became an honorary member of the Royal Astronomical Society in 1838. And then finally, John Herschel, the polymath influencer, right? He was interested in so many different sciences, and he was so good at it. And he also influenced scientists himself. But he was born in England, right? His father was from Germany. His aunt was from Germany. His mother was English, and he was born in England in the UK. And he was raised by these 2 amazing scientists, his father and his aunt. So that helped him pushed him towards pursuing science. And he was an influencer of sciences and scientists. So, for instance, he would write books on how to do science, something that actually someone you may know, Charles Darwin, read this book that John Herschel wrote so he could become a better scientist. He wrote How to Do Astronomy that influenced countries like China in their own pursuit of astronomical information. So he was really good at all the different sciences, excuse me, geology, chemistry, biology, physics, and he was often mixing with these scientists and talking to them and coming up with ideas and helping them solve their problems. And in that, he invented a new photographic process. So photos, how many of you love to take photos with your mobile phones? Raise your hand. Who likes to take photos with? I know I do. I love using my mobile phone to take photos. I was just taking some photos. Okay, I see some hands also. Thank you. And John Herschel, he's the one who penned the name. He invented the name photography. John did. He also invented these terms positive and negative for film. And I know film is an old term, an antiquated term that you're probably not used to because you know the digital device. You don't have to develop film. Well, here's film in the bottom right hand corner, and we have an example here of a positive piece of film and a negative film. So he coined these terms, these words for these new things that were being invented at the time. They didn't have film they didn't have film at the time. He created some earlier earlier renditions of film. We didn't have this celluloid, this kind of plastic yet. He was just using glass actually. But this is just examples of kind of modern photography that we have. We've gone from film to being able to use computers and develop images on our computers. Here we got a positive and a negative to just a click of a button on a small mobile device. Well, what he did was he was working with chemistry and with paper, and he invented this photosensitive, photo meaning light, photosensitive paper, and using chemicals that he would brush on paper that would then process in the sun. So he was able to start making photographs of real life. And you can see here's a photograph of someone standing outside. This is a postcard. And you can see these have a blue tinge to them because this is the chemistry that he had at the time. And this became known as blueprints, possibly also another antiquated term that you're not familiar with. But if you ever build a house, you can have a big blueprint of the building and the walls and the windows of everything. We call that a blueprint. It's now, I think, white mostly, but it used to be mostly blue with white lines. But that's where cyanotypes came from. They came from John Herschel. And so he was using the sun, our star, to process this paper with this chemistry. And it was using ultraviolet light. So that's actually on the other side of the electromagnetic spectrum that I thought I'd show you. How many of you are familiar with the electromagnetic spectrum? Has anyone ever seen this graph before or anything like it? I don't see anyone in my school in Turkey. So I will quickly explain what this is. So this is a wavelength of light, and we get all these different types of light from our star. Everything from radio waves, which helps you listen to radio or even use your mobile phone or watch television, to microwaves to help you warm up your food, infrared. And if you remember, William Herschel discovered infrared. You might be using this to heat your house. Visible light, this is what our eyes see. An ultraviolet light. Here's what John Herschel used to process his photographs. He didn't discover, excuse me, ultraviolet, but once it was discovered, he used it to do photography. But ultraviolet UV light is dangerous. You have to be careful. You have to wear sunscreen so you don't burn your skin, but it can change using the melanin in your skin to get darker. That's ultraviolet light. And then of course you see X-rays and gamma rays, which are really dangerous. You don't want to, you want to be careful around those. So infrared was that one wavelength that his father discovered. And then John used ultraviolet to create these cyanotypes. So in his understanding of all these different sciences, he put them together to create the first glass plate. He actually took a picture. You can see, does anyone recognize what this object is in the upper right-hand corner? It's his father's 40-foot telescope. He took the first glass plate image. And photography was changed forever from then on. You can see here's the negative on the bottom, and here's the positive of that image of his 40-foot telescope. This is actually a picture of the young John Herschel, not young anymore, actually, he's old. And he kind of looks like a mad scientist, but he actually did that on purpose. He scruffed his hair up to make the photograph look more interesting. So, this image of him was taken by Margaret Cameron in 1867, Julia Margaret Cameron. And I just want to show you some pictures of some of the workshops that I do around cyanotypes. We were making our own glass plates. We're using ultraviolet light here. These were white beads turned colorful in the sun of ultraviolet. And we were using ultraviolet lamps, UV light here, also known as black light, to change the color. You could see a white bead on his palm, but when you put it in ultraviolet, it turns all these different colors. And these are the young scientists I had in my workshop who were making their own glass plates and then took them out to the sunlight. Here we have John Herschel himself. No, he was an actor playing John Herschel. Go back to that. And he was exposing his cyanotype to the sun. And then we processed it. And here's what they look like. You can see them being, it's just water that we used and a little bit of vinegar to pop that blue. You can see how bright blue, and their images were put on forever on paper. And that's what John Herschel discovered. So John Herschel actually was the co-founder, as I mentioned, of the Royal Astronomical Society. We were founded in 1820, over 200 years ago. And he made his father, Sir William Herschel, the very first president. And you might notice that we formed in 1820. Here's William Herschel's 40-foot telescope was our first logo for 200 years, and that he did not live for very much longer. He died 2 years later after becoming president. So an amazing story of this family. Here's our logo today. So let's just see if it plays. Trying to get it to play. There we go. That is our logo today. In 2020, we turned 200 years and we created this brand new logo for the Royal Astronomical Society. Okay, I promised you a quiz, so I'm going to go to hopefully the next slide. Here we go. It's not really a quiz. So it's just some fun stuff. You can pretend you're William Herschel, and let's see if you can tell in these images whether they're a potato or a planet. Maybe it could be a moon, or maybe you should call this spud or space. Okay, so what you and your teacher are going to do is I'm going to show you one image at a time, and with your teacher, she can figure out what he or she can figure out whether you think it's a potato or a planet. Okay, let's get started. Are you ready? If you're ready, raise your hands. Are you guys ready? I'm looking in Turkey. Raise your hands if you guys are ready. No one's ready. Okay, I see one hand raised. All right, here we go. Number one, potato or planet? You can work with your teachers in your classroom. What do you guys think? Potato or planet? All right. Hopefully you guys have decided whether your classroom thinks that's a potato or a planet. I'm going to reveal the answer. It's a potato. Well, it's a sweet potato, a yam. So if you thought potato, you were right. Okay, next. Here's you ready for the next one. Here we go. Potato or planet? What do you guys think? Give you a few seconds in your classroom to go decide whether you think it's a potato or a planet. All right, here we go. Hopefully you guys have decided. It's a planet. How many of you knew it was a planet? Raise your hand. Did you guys know it was a planet, I hope? Let's see. Does it say the name? I cannot move this thing, so let's go. It's here. Oh, yes, Mars. Good. So it does show you what it is. Mars. Excellent. Okay, the next one. Potato or planet? I hope I'm still sharing. Potato or planet? Okay, here's the answer. Okay, not a planet, a moon, a celestial object. I can no longer see you guys anymore, but that's okay. Here's the next one. Potato or planet? You guys decide in your classroom whether you think you're potato or planet. And it is a potato, the very common russet potato. Makes lots of really good, we call them here chips in England, but back in California, we call them French fries. Okay, next one. Potato or planet? And that's a potato. I'll skip that one. That's a purple potato. They sometimes and then you cut them open, they're white inside. I think these are also called yams. Potato or planet? Okay, we're gonna go forward with this. If hopefully you've decided. It is a planet, the planet Venus, which is a greenhouse effect gone awry. It is so hot, thick sulfuric clouds, acid rain on this planet, and extremely volcanic. It has so many volcanoes on this planet, on Venus, and it's the second planet from our star, the sun. Okay, potato or planet? Look at all the swirls on that. I wonder what's going on in that image. And hopefully you know it's potato. That's right, opposite. Sometimes inside potatoes are purple, or this is taro root. Not sure, but yep, type of tuber potato, we'll say. And then finally, potato or planet. And this is very well known in England on our Sunday roast here. We have roasted potatoes. They look so delicious and tasty. Sorry, I hope you have lunch soon. I apologize. A potato, not a planet. I hope you had fun learning about the Herschel family and deciding whether it's potato or planet. And thank you so much for being here this morning with me. I'll just wait for Nasia, or I'm not sure if, is it Lubia?
Me. Hello. Hi.
Hello.
Hello. Yes. So thank you so much for your incredibly beautiful talk and insightful. I learned personally a lot. And we do want to start a small questions section right now, if you don't mind, because it's we usually do that after the lectures. So I will maybe start with a small question to you, because
do my best.
Because personally, me, when I was at school, for example, I always had this very hard moments to understand how to enter science, right, and how to enter astronomy, because even if I have a phone and I start to make like a citizen scientist some photos, it may not be easy. So what is your advice for people who want, well, young people who are at school now, to even at school, to start to enter science? Maybe you can list some websites where people, how they can upload their photos from the phone of the planets that they do, right? Kind of to have the same path of the Caroline, right? Who was doing this maybe.
Yeah, that's absolutely right. So, and it's interesting that your question includes the word photograph, which is something that came from John Herschel, from one of the Herschel family. Yeah, so there's something called becoming a citizen scientist, which there are lots of different organizations who need your help. So one in England is called Galaxy Zoo, where you could go to work with the University of Oxford Astronomy Department and help them classify galaxies and nebula. This is some of the work Caroline Herschel actually did. So you could become Caroline Herschel and volunteer your eyesight in helping them classify different objects. And it's for free. You could do it just for fun. And that's called Galaxy Zoo. I will write that in the thing here.
Yes, please.
Galaxy Zoo with the University of Oxford. There's also like SETI. SETI is the search for extraterrestrial intelligence, and they're actually in my home state of California, the United States. There are some citizen science things there, but if you just look up citizen science, you Google citizen science, and maybe actually also add in astronomy there to that, they could probably come up with lots of different links where you could take part and volunteer your time to help look at some of the data. There was one with astrogel, this very thin, light gel that they sent out to space to collect space dust. And you could help them look through all the thin sections of this astrogel to find space dust for them to look at closer. So that was also a citizen science thing. But maybe you want to start an astronomy club at your school. If you can find a teacher who is interested in hosting or chaperoning an astronomy club, and then you could find some ways to raise some funds to buy your own telescope. Or there's a lot of remote observation things. Or maybe you guys just want to hang out and watch some astronomy videos or space science movies even, and talk about the physics of that, to learn more about the physics of that. That's a really good way. Here in the UK, we do GCSE astronomy. That's not a core part of our learning in our schools. It's an extra exam you could take, and that most of our students here in the United Kingdom learn on their own. So if you do GCSEs in your country, then you could look online. There are GCSE online astronomy classes from everywhere around the world, and you could join one if you want to. Some of them are fee-based, and you can start your path towards astronomy that way as well.
Thanks a lot.
Yeah.
Thanks a lot. Yeah, I heard and I love these citizen science activities, because even without being a professional, you actually can create a lot of contribution for science. But did you personally work with any of the citizen science observations in your work?
In my work, I've done SETI when I was younger, actually. I volunteered for the Mars Society when I was younger. And that's actually, and I worked my way through every single position in the Mars Society, all the way up to executive director. I was even science director, but that was all volunteer. So yes, I said I wanted to be part of the Mars Society, and it was a volunteer nonprofit organization. And through that, I got to work for NASA. So see, you never know where volunteering.
That's a path.
Yeah, some of your time goes. And now I'm here at the Royal Astronomical Society. But of course, I completed some science degrees and some art degrees as well. And so that's what got me to here. Yeah, just by interest and finding like-minded people. There are people out there who think and enjoy the same things that you do. And you just need to find them, get together, and see what you can create.
Thanks a lot. Yeah, I also really love the citizens activities, because they actually, as you said, they may be an entry point, right? But also they may allow the observations to scale at some moment. The only issue which maybe, as I understand, is the quality sometimes, right? That you need to trust the quality. But that's why I ask if you worked also maybe with observations made by citizens, because sometimes they can also be not as, I don't know if you agree with this actually, that they may not be as good quality, right? So
what I would say then is check out universities that have astronomical departments, astronomy departments. Those astronomy departments in those universities are doing things. It's part of their remit that they have to actually do things and share their science with the public. So they might be having events, public events, to share some of their research. They just on Saturday, two nights ago, I was at the University of Reading, and we were participating in NASA's International Observe the Moon Night. So we had telescopes outside and we had members of the public come and join us. We did some talks about the moon. And then we had the Reading Astronomical Society set up telescopes and everyone could watch the moon up close. And so those are some things. So check out your local university and see if they have an astronomy department and see if they're doing any public events. That's another way to find out actual real scientific work in astronomy.
Okay. Well, that's already a lot of things to check. I mean, the universe, and indeed, I personally really love them and what they do. We worked with iNaturalist, which is more on Earth, citizen science on Earth.
Yeah.
But it's,
well, some of it, I mean, the astrogel was in space. I do remote observation. So if you go to the Royal Astronomical Society YouTube channel, and I don't have it here, but if you go to our YouTube channel, I've been creating online content, and one of it is exploring professional astronomy, and you can go on a journey with us where we were looking at Jupiter and Uranus and Neptune through ground-based telescopes from Mauna Kea called the Keck, and also the Infrared Telescope Facility, the IRTF, NASA's IRTF in Hawaii. And we were in England. I had an astronomer in Japan and others in other parts of the UK, and we were remotely observing these planets, and we recorded all of it, so it's all on our website. If you'd love to see what astronomers do, you can check those out.
That's great. Yes, because I hear a lot of people, they have this, idea that it's not possible to contribute unless you work for NASA, right? But it's actually opposite. That there are thousands of ways to contribute and find the community. And I'm really glad you did.
That's absolutely right. That's exactly what William Herschel did. That's exactly what William Herschel did, is he found a way to contribute. He was just an ordinary person who did extraordinary things and made incredible world changings and solar system, universe changing things. He doubled the size of our solar system just by inventing a tool to help us find it.
Yeah.
And then that other astronomers of the time did not. They were well educated. They were working as astronomers, but they did not find this planet. Just William Herschel did.
Yeah. Are there questions from the schools also?
Were you asking if there are questions from the schools?
Yes. Yes. Because if I guess that there are contacts that people usually write.
I'm Lucinda Offer, Education Outreach Officer for the Royal. Sorry about that. That was my fault.
Okay, wait. Let me also check something. Royal Astronomical Society YouTube is, yes. I mean, all these questions, all these websites, we may also spread out this in the for the schools in the Discord
I just posted a link. I can see some people. I can see 2 different classrooms. Were you going to take any questions from the classrooms? I don't know.
So I'm asking also that indirectly for schools, because I think that if there are no questions right now.
Okay, well, I'll answer probably the most important question, which is, what is my favorite planet? My favorite planet is Mars. Okay.
I will not ask for the explanation, even though I would love to. Why it's Mars and not others?
Well, Earth as well. Earth's pretty important.
Yeah, it's pretty important. Yes. I also wanted maybe to ask the last questions, if there are no questions from the schools. So, there are a lot of discussions about flights to Mars right now, and it's not related to your lecture directly, but people always wanted to make sure that they reach other limits, right, and more limits. So what do you personally think about this trips?
Humans to Mars. So I've spent 20 years advocating for human space exploration, specifically humans to Mars. I have been executive director of the Mars Society. I have worked amongst lots of people, even Elon Musk back in 2006. He used to come to our conferences in 2001. He came to an event we had at Stanford University, and he gave the Mars Society, I think, $100,000 at the time to help us with our organization. Um, there's a lot of things going on in the world. I know when we were during COVID and lockdown, I did wish that more humans were off, on Mars, if I'm honest.
Yeah.
I wish we had more further with colonizing other or settling on other planets. I know that ESA right now wants to create a moon village. They want humans back on the moon, which I think is a great way to get humans back out there. It's dangerous. It's risky. It's a serious and it's difficult. It's a difficult thing. But I think that human beings, we are like William Herschel and his family, are intelligent. I think that we are clever and that we are capable of building the infrastructure that human beings would need to not just arrive on Mars and not just survive on Mars, but can thrive on Mars. And I think that's what we're going to try to do on the moon. It's a completely different environment on the moon. There's no atmosphere. There's no protection from that sun. There's no magnetic field that protects us from coronal mass ejections like we've just recently had earlier this year when we saw this aurora. So it's a very different landscape on the moon than it is. And Mars is a lot more Earth-like in that sense. It has an atmosphere, a very thin atmosphere. Maybe we can thicken the atmosphere. We're good at thickening Earth's atmosphere, unfortunately, not in a good way, but maybe that's something, technology we can use to thicken Mars' atmosphere, warm the planet up a little bit, increase the pressure on the planet a little bit, just so that humans could walk on the planet with maybe some smaller pressure suit and a bit of oxygen. And of course, it's going to take years, thousands of years. So this is something that I'm leaving to the young people of today to carry on that torch for human space exploration if they're so interested. Because the plan was, as an American, after the missions to the moon, those Apollo missions where we landed on the moon, was to go to Mars 8 years after. But of course, every new president in the United States, the space program changes, and that's why every 4 years our space program is something different. But what I'm hoping for now is, now that it's more a serious subject, that other countries around the world can see that it's possible. It's difficult, it's hard, but not impossible. That more countries will take part in human space exploration. And I know that since I've worked in humans in this field, that India, it has taken part and have landed, have sent objects to Mars. China has built their own space station. They've sent a 3-part mission to Mars, to orbit Mars, to land on Mars, and to rover around Mars. And they've also sent a mission to the other side of the moon, where no other country successfully landed. And they have a lander and a rover on the far side of the moon, the side of the moon that we don't normally see, which is really exciting. And they want to also go to Mars. So hopefully other countries, even small countries, can contribute to this. It's expensive and it's dangerous, but I think if we pull all our resources and our intelligence and how smart we are and good at solving problems, then I think it's something we can do.
Well, thanks a lot. I would love to discuss with you more, and if wherever we will meet again, I would love to continue our discussion. Thanks a lot for your beautiful, inspiring talk. Personally, I would really continue my astronomical endeavors if I would meet you when I was at school.
Yeah,
So,
I would love to come back and do a talk on Mars and the work that we've done.
Yeah.
We've been doing for 20
We
years.
can
And it
think
was
of
lovely
continue
being with
this.
all these classrooms in this morning. Thank you so much for inviting me. I had a lot of fun. I
Thank you
hope
so
you did
much.
too.
Yes, we will spread it around. So some people who couldn't join, they will listen. And we also have a citizen science collaboration in lectures with that border. So we would love to also maybe share with you and invite you for open table on that.
Wonderful.
So we'll keep in touch.
Thank you so much. Bye, everyone.
Thank you. Bye-bye.
Thank you.
Bye, everyone. Bye.